Test, test. Welcome. Welcome to the Programming Games Club. Welcome to the program. Yeah, sounds working okay. Good. Interesting. Sounds working okay, is it? Really? Yeah, stuff it. That's not right. Alright, let's get this sorted out. Things aren't going as they should. Let's get your videos sorted. Problems with videos, yes. Okay. What's going on? No sound. That was the biggest one going as well. That one needed sound. Oh, you stupid, stupid system. Oh well. The world will never know why. I gave a really good dissertation in that one. A rant, you would call it. Because people are stupid. Well, yeah. There we go. We can add that one to the playlist, I guess. How do I save that? Title required. Why? Oh, pig off with your catchy titles. You need to answer this question. Yes. No, it's not made for kids. No, it's not made for kids. Piss off. Undo changes or save. Until errors are resolved. There you go. Errors have been resolved. Good grief. Okay. Can you get it off the screen then? Thank you. Tough. Things go wrong. There you go. And if it goes wrong again, then I'll stop using OBS. It's not a problem for me. Why it decided not to include the microphone recording, I don't know. I have no ideas. Alright, back to today. Good, we're still... Will you stop coming back on automatically? Stream chat. We've got a viewer. Hiya! Hey, it's Polly. Yeah, the last video didn't record the sound. So, I hope the sound's okay for you watching. If it doesn't record today, OBS is going to bye-byes. Alrighty, it's Polly, so Polly needs to know this. I'll do this for you, Polly. Remember, you have to go home. We came up with all of this stuff about let's make an item warehouse. That's what today's about. Database, no. Let's make an item warehouse. And we went through all of this thing about item warehouse, which has no voice recording on it at all. That's going to look stupid, isn't it? And yeah, we thought of all of these glorious ideas and came up with this. This table of models, category, tree models, containing items, tokenization. How can it be simplified? Easy. I'll show you how it can be simplified and I'll tell you a story. No, that's perfectly alright, Polly, but thank you. Thank you for the reply. That is what I wanted to do at the end of last episode. So we are going to do this today, by the way. Actually, I'll turn the machine on that's going to do it. And we'll get that up on screen, shall we? So yeah, we're going to do some code. You're going to love the code. Because Polly and me, we were talking about this as I started doing it, and he said, oh, you're going to need something quite complicated to do that. And he was right, we are. We're going to need something very complicated to do it. Here we go, here's the machine. That'll do, won't it? I can swap my skis. Hello, my skis. We might need a keyboard. And I've got good news for you. GitHub's up and working. I'll show you that first, actually. We have GitHub. Under Fraser Blade Sharp, and we now have Rana. If you view the code for Rana, it's got everything in it now. It's got the Midnight static library, and we're doing utility development at the moment. So I'll take you through the changes, and then we'll do today's. There's a change. I actually, if anybody's been watching the streams, I've been skirting around a piece of code. And let's have a look at that piece of code. I also wanted to change that over to the side, didn't I? I remember. I'll do. We're on the last session. And this piece of code was in the utilities, and it was this file, this readme text, and it was as if I was ignoring it, and I wasn't. It's because I didn't know what to do with it. And I woke up yesterday at around 4 o'clock in the afternoon and knew the answer, so I wrote it. There it is. That's the whole file as it now stands. I added remove the end of file character and turn the thing into a list. The list is passed in, so we don't need to return it. It's passed in by memory address. So we alter the memory address directly. The result is amazing. Instead of getting that bit of uselessness that we had before, which was just one long line, we now get a string, a string, a string, and an empty string. And that's very important. You'll see why later on. You need that empty string. There's a reason for it. So now we have a comment, a staff, a dagger, and they're separated. They're in a QString list, an array of strings, designed specifically for that. This thing is brilliant. Yeah, we have it sorted. We have something that's usable. Shall we have a look at the code that generates that line? I need another keyboard. This one ain't going to work. I don't know what I've just done on the main computer now. That keyboard works. That's lucky for me. I've got another keyboard, isn't it? Let's have a look at that main program. Look at it. It's 2 lines. You tell it where, you give it a file, and you send that file in with, oh no, it's 3 lines, because we needed one of these. A QString list. I'm using the referencing system so it kills itself properly. If anybody wants to look at that referencing system, let me know. Hey, we've got somebody. Is this Pop OS? I have no idea. If you want it to be, it can be. Have we got Pop? I think we might have, if we're lucky. I'll work on any operating system. Operating systems don't bother me. But I like that one. So all we do now is we can use the utility we made, chuck in a file name, throw in our QString list, which you don't need to use as a ref, by the way. I just use, it's a pointer. A reference is a shared pointer. It's not in here. It's in midnight. So for anyone who doesn't know, I write my own thingy for that. It's in here. So a reference, or ref, is a shared pointer from the std library. Memory. Comes out of the memory library, standard library. So it's just a shared pointer. That's all it is. It's just that it looks better if you put it like that. So I created one of them, threw it in, and out comes your list. Isn't that brilliant? That is a utility, that's gold. I like that one, by the way. Thank you, Nifty Wifty, for making me smile. The first person to make me smile today. That's awesome. Okay, let's get back out of that anyway. Let's get back over to utility development where we're supposed to be, shall we? Thank you. Why won't it go back? So those are the changes. The changes are all in utility development here for you. It was under utils and it's in the CPP file. You'll now see that we're using Qt to remove the last end of file character and to convert this qbyte array into a list, a qstring list. So that line does that for you. And I've got a double colon, semicolon there, really? Have I? Not needed. Not an error, but not needed. A blank command is allowed in C++. Strange, isn't it? So today is about this really complex thing, and I wanted to tell you a story, didn't I? So it's about this item warehouse that we're going to design today. It's in the namespace night for midnight. It will be transferred over, obviously, to the shared library. So the namespace is there for it. The CPP is massive at the moment. It's that. It's got nothing in it. It should have that in it, because it is. Alright. Can get rid of utilities. We'll just concentrate on these two files. So, header file. Yeah, it's using old school. There's no pragma once here. Bloody hell. I should really go around putting pragma once in, shouldn't I? Who cares? As long as it works. Right. Right, peeps, this is it. This is the biggie. There was a guy, Mr. G, who worked at one of the very, very, very first companies that were introducing things like the IBM to the market. And one day, they wanted an item warehouse out of him. And he sat down and he called a meeting, and on a big blackboard they put down all the ideas. Okay, and we've done that. We put down all of those ideas. That's the wrong mouse for that. How many mice have I got here? Jesus. So yeah, put down all of these ideas. And here's his ideas, by the way. This is what they came up with, all of these ideas here. And he took this home with him in the evening, like he always did, to think about it. And he switched on his IBM and started thinking, well, how the heck can you code something this complicated? And his kid was there. His kid's 13 years old. Just going on 14. 14th birthday. His dad's promised him a brand new computer. So he's dead interested. And he looks at the screen and he says to his dad, but Dad, you've already done an ECS system. It's golden code. What do you need all that for? And his dad looks down to little Gates Jr. and says, God darn it, son. One day you'll be a billionaire. You're right. What do you need all of that for? The kid went on to be a billionaire, as we all know, and developed one of the worst systems ever. Goes to show that kids don't know everything. Right. Story over with. What was he telling his dad? We've already got an ECS system. Will this work? Not on this mouse. Haha! Godfathers, these mice. Poppy, I've got mice everywhere. Will you catch them and kill them? Thank you. Let's go back up to the top of Rana. ECS. You see, we've got this ECS system here. Just have a look at the scene header file. So it's a scene header file that's the biggie. It's this. That's all there is. That's your ECS system. It's golden. Look at it. But what does it have? It has a public typedef struct object. So what the heck do we need all of that garbage for when we've already got it here? Well, let's start filling in the includes. We can include how are we doing the includes in here? Just out of interest. Putting in source night common. Damn it. Can I put in source night common here? No, I can't. I've just got to put in night common. Okay, I've made a mistake then somewhere. My bad. And this is in ECS scene H. Okay. Which means it's an object struct entity. You just need that. That's in public. That's why it's const. We can put this into public or private. Doesn't really matter, does it? I don't know. Let's just pop it in here then. Let's call it weapons. That will be scene, won't it? And there you go, that's it. We've now just created an item warehouse. That was very, very difficult code to get through. Maybe we could do a little bit more. What kind of things? We haven't really got... we have void initialize and we have an add entity. We should really start standardizing how we're doing this. Because at this stage, we're now starting to get into multiple files, which could be a good idea to standardize them. So we'll do a void initialize, because I'm in the mood for that. Do I need to make this at all? Don't think I do. It's a pointer, isn't it? Oh, we do. Okay. That's fine then. No idea why I did it that way. Again, that needs standardizing. We'll put an M underscore. It's not a member variable. Well, it is. I don't really want it to be a const. We can put private in. Yeah, that'll do. Give that a bit of space. Let's tidy it all up a bit. Make it look like I actually wanted to do something. Does it need a destructor? Yes, it does. So, item warehouse. We shall destroy you. And I think we'll have that initialize. Yeah, we'll have that as well. Probably won't use it, but, you know. Things are what they are, so we're not going to keep that empty. I thought we were. Never mind. Initialize. Refactor. There we go. We've now got our full item warehouse. Every single thing that we can ever want to do. Pretty interesting. Oh. That's not helpful. Now it works. Weird. Things aren't working the way they're supposed to today, so we're going to have some fun. Oh dear. So here we go, item warehouse. How do we do it? We do it quite simply. We make a new one of these. Oh god, what did I just do? Control Z. Oh, thank God for that. For a programmer that programs with one hand, I do quite well, don't I? Here we go. So we'll make that equal to a new whatever we called it, Q vector object thingy. Yeah, that'll do. One of them. And we just put that at the end, and now we should be okay. Okay, reference. Did I mean to call it with no arguments? Ooh. Oh, I see. Really? Doesn't help if you do stupid things like that. Alright, what's going on here? No viable overload equals. Am I going nuts? Weapons. What's wrong with you? Told you nothing's going to work today. Q vector. Object and registry. Ah. There we go. Done. I'm happy now. That's set up right. Thank you. My bad. Right, in here we do need to destroy it. So to destroy a vector, we have decided to do it in the following way. We take our weapons and we shall clear them. Like that, and then we shall delete them. Clear the data, and delete the weapons. That's the way we decided to do it. Fair enough, we'll take that as that then. Let's initialize it. Let's have a look at main on how we would like to do that. Alright, so we already developed this code. Pop it in here. What don't we have? We shouldn't have that. We'll take one of them. We don't have the QD bug, which is fine. We don't need it. We don't have utils. We'll pop you in, because we might need you. And we'll have an include for our utils, shall we? Which is, for now, utilities. It's source. No. Lowercase. Source, core. Utils, there we go. Sorted. Well, hey, we're up and running. We'll give that a save. We'll give that a save. And we can now blow this up and get this sorted. Didn't take long. So here's the interesting part. We don't have any items in our ECS system, do we? No, we don't. So here in Midnight, we initialize for our entities. We add an entity. And each entity is given a base component. And that's it. We haven't really decided too much about this, although we did try a little like sub-project called Sandbox where we messed about with this ECS thing and we made a character walk around a screen, which was amazing. Okay, so we can add an entity. I'm okay with that. So let's try making some item type thingamajiggies. Go back to main. That's a test for text file input, that's fine, that can stay the same. Next test. So, test and display a simple item warehouse list. Alright. We'll put it into its own little thingy, scope, so it doesn't mess about with anything else in here. And we'll have to include it. Is it working at this point in time? Well, no. No, I'll have utils, please. Oh no, that was right. Damn you. So we can have it's going to be an item warehouse, isn't it? So it's night. Item warehouse. We'll just call it items. I'll make that shared reference. It'll die at that point, won't it? Yeah, that will kill it. If I make this into a reference, it'll die there. That'll do me. So we have to keep it within the scope. It's just making sure that it doesn't bleed everywhere. So I will have a night. Ref, please. Open the thingies, close the thingies. It's just called items. Equals make reference, isn't it? Create ref. Night. Item warehouse. With nothing. Oops. That'll do it. Yeah. Right, so this pointer will die when it hits that bracket. It'll get wiped out, deleted from the system, and all the resources will be handed back to the operating system. So that's good. So we've got these items. We want to initialize them, don't we? So we could do items. Initialize. Like that. If you're not used to dealing with pointers, pointers can be awkward if you don't deal with them properly. You can have memory leaks. I'm just protecting the test system from memory leaks at this point, which I don't really want. Right. What do we want to initialize then? We want to initialize this here. We've got a storage object. We can store objects. We want to initialize, so we're going to have a list output. We're going to go into this file called item data. We're going to read that file and put a list of strings here. All right, that's a good start, I think. We need to know what object takes. So we need to know what this does, this object thingy that we've made here. What does it store? It stores an entity ID, which we don't have. A QUUID, so unique identifier, which we don't have. And it stores components, which we don't have. So we need a scene. See, we can't have items without a world. We'll need a world. Okay. So I need somewhere to place all of these items. We need to place these items into something. A world. I think we can do that. So we will have a scene. Would that be a shared pointer? No. Wait a minute, class, scene. Yeah, we can do it. We're allowed to. I've just got to be careful what I use this reference for. We'll just make it a scene. We'll just call it the world or something, I don't know. The world scene. How do you spell world? Is that how you spell world? Really? It looks awful. It is. Oh well. Let's make it a member variable. And we will not be passing this in itself like that. We will take it in here. So we will have a ref, scene. And we just want it by reference because we will be taking it from something else. And we will call it the world. Or world will do. Like that. We'll pop that into here. And mworld can now equal world. Like that. Pretty simple stuff. We'll just have that. All right. We now have a world. So when we create our items warehouse, we need a scene. Do we have one? We do not. Comes under ECS. And it should come here. Hash include ECS. Scene. We'll take one of those. We'll make a reference. Right. ref night scene. Remember, I'm doing this outside of. We'll just call it scene, and that equals night create ref for this night scene. Yes, night scene. I like that. That's funny. Yeah, that'll do. Don't need to pass anything in. Item warehouse takes the scene. Alrighty. At this point, I'm just doing a check because I don't think I got that right. No such file or directory. Where's this? Of course there isn't. Silly me. Everything's saved out, isn't it? Can we just open Midnight just one moment? We changed something, didn't we? Okay. Huh? Oh, god damn it. It's taking the project from here. Why? There's nothing wrong with this. Don't be so silly. No, that's fine. Source night common, no such file or directory. Source night common, no such scene /4. That's because we don't have our profile correct, and I thought this was going to cause a problem. It's here. I've got source being added there, and it shouldn't be. Right now, all our files are wrong. Fantastic. And these should be external. And I haven't marked them external. So that's external. That's external. Utilities is still internal. This is getting confusing. All right. Main. So you can tell now which ones are external. Great. Okay, header's fixed. Nearly. I denote externals with angled brackets. Otherwise, I think I can find them in this. And you can't. Right. Everything's now set properly. We have the correct notations everywhere. Things have been cleaned up. Good. It compiles. Better. That's all we want it to do. We don't want it to do anything else at the moment or anything stupid. Right, let's see initialize. We now have a scene. We now have items. Alright, we could have registered the scene here. But that's a bad way of doing things, so we're not going to. That looks better. That looks a lot better, that's working. You can put messages in here, by the way, to make sure that things are being cleared properly. I know they are, so I don't care. I used to put a message, like destroying the item warehouse. I would put a message there to print out on the console. And then I could see in which order things were being destroyed, which becomes very important later on. Especially if you program things badly, like I used to. So we've got a file. We've got a list of outputs. We don't know how big that list is. We also need to get rid of these. That's not. Those are irrelevant now. We have these instead. All right. There's your base. What can we do with it? How can we initialize an item? Well, here's the interesting thing. Do we have the ability to initialize the item? No idea. But we're going to try. How would we do it? It's got to be generic code, because it might not be weapons we're doing. It could be top hats for all I care. Could be a list of hats. Could have many categories. We've just got one. Alright, I think we might need to program our... Yeah, we'll have to go into dual programming, won't we? I was trying to avoid this. What the hell, why not? Alrighty, give that a quick save. Alright, we are going to open Midnight up. We are going to set development though as to the main. That's fine. And it is the ECS that I'm interested in. You, I'm definitely interested in. Pop you there. So, alright, we have add entity. Okay. And we have the object. That doesn't seem too bad so far. Don't really want to mess about too much in here. More interested in this initializer. Alright. We can take our scene, which is now our world. We can add an entity. And yeah, we can do that. How can we use that? We can use that to create an object. But before we do that, we need... We didn't... Good, we didn't. No, I don't know what that's going to return. I've got no ideas, it's just going to give us an integer. Which is fine. So the entity ID will know. Base components position, it actually gives us an object. Where? Where's it putting that object? Into the registry, yeah, okay, that's great. We don't really want that though. Nice having an object, but... What I'm thinking is, should we be returning an int, or should we be returning an object? Yeah. The object is more useful than the entity. We can get to the object through the entity, but that's dangerous. It's a pointer that dies at the end, but it gets pushed in. It's kept alive inside the registry. Okay. So we have a pointer being kept alive inside a registry. This is where we have to sort the solutions out. This is where the real thought comes into it. The complexity. Remember all that garbage we wrote down for the idea? Well, this is where it is. It's in this few lines of initialization. Right, we can get the object. Let's see how that would look. It would look something like a scene. How are we treating objects here? Okay. Object. Star. Item. Object. Equals. We have a function. By reference. Const, we can't alter it, okay. What? We can't alter it. And this is why we have this need to be kept in sync with, I've got you now. Alright, at this point we need get object. Because of the way we've done it. We can't put it equal to anything. I don't want a registry view. That's useless to us. I need that entity object. Up until now, we haven't needed it. So what we need is an object star. Get object. And it's int base entity. That will just return us registry. Base entity. Q vector type scene object star aka Q. Oh, it's a Q list. Function. I don't want to do int entity. We have a synchronization match. Shouldn't need to. I just want the object part. I don't want the Q vector part. I want the object which will be at that. No? Oh, come on. Where are you? That gives me a pointer to the base entity. With an R value of type Q vector. Q list. Why are you doing that to me? Because there's a better way of doing it, it's Q vector. God. Where's the data? There it is. Alright. So we have to use the data variation. How do I get rid of this? What's happened? Where's everything gone? Oh, here. I want that data entry. Dot. The dot? Data. And that's a star, so I do need the reference. There we go. A dereference, sorry. That should give us the object. So, that will be our world. Get object. Items. Okay. We now have a base item object. We could call it base item object, couldn't we? This is the object that covers every single item in the world. So for a weapon, we just need to go through this list output, don't we? And add the weapon component. Or the combat component. We don't have a combat component. What am I talking about? God knows. Alright, we now have that. That's working. We have position. Let's have a component then. Let's call it combat. We'll call it combat component, I guess. We'll do that, and we will give it an int damage. We will also give it a Q string. Name. We also need a UUID. That one. I think that should do. For a component. The position component doesn't have a UUID because everything has a position, including this item. This item will come back with a position already attached. So, for our lovely read text file here, we now have a list of outputs, which is good. We have a base object. We need to make a new object. For each of the items in our list, we need a new object. So, for each queue string, I'm definitely going to have to get these right sometime, you know. Where's this gone? Here it is. I keep forgetting that that's a do free. For each queue string, a line in list output, we would like to do the following. List output is what? Oh. It's one of those, isn't it? Oh. Ah. Let's use a for next loop then. For. Ah, this is why I needed it. I remember now. Remember I said there was that space at the end? That blank one? This is why we need it. Because index... Remember, this is... It's list output count, isn't it? I remember now. Dot count. Alright. Semicolon index. Now remember, the count is going to be one more than we actually have. So it's a less than sign, not less than or equal to. And that's what we needed that extra space for. So we could put that less than sign in. Sounds stupid, I know. But it works brilliantly in computers. So for each of these list items, we have a string. So we want list output 1, or 0 in this case. Is there a prepend to a list output? We're doing string lists here, aren't we? Come on, I want a prepend. Inherits queue list. I bet it's in there. Yeah, it'll be in there. On front. Oh, we've got a data pointer. Okay. Oh no, it's an ends with. Begins with, I want. To the first item in the list, that's not what I want. No, it isn't. Right, let's get the data first, and then we'll work with the data, I think. We can use QString. And it's exactly the same, isn't it? Yeah. Alright. Just trying to work out a sentence for that. I want the string at index position. So we need a QString. We'll call it line, I suppose. Equals the list output. At index. And we'll take dot data. No dot. What? I can't access it this way. Why not? It's just a nightref QString. Ah. Oh, that's not good. What have I done badly here? It's a pointer. Can we... Unqualified ID. Yeah, I know. Ah. This is where the referencing system's going to cock me up, isn't it? It's a shared pointer. And we're going into lambdas. Don't really want to go there. Right, so what we got? shared pointer. It does not provide a subscript operator. No, it doesn't. So we need a pointer. We need something to point to that string. We need an iterator. We've got an insert iterator. Can we get a QString out of this? Oh. Okay. Return the stored pointer. Alright, now couldn't use the index. That's a good point. It's at. Huh? At? What do you mean, at? Returns the item at index position I in the list. Thank you. At. That will be index. There you go. Found it. That will give us the first line. Alright. Let's make some really rubbish code now. Because now I've got a QString. What's the first character? What's the first character in a QString? It's at 0, isn't it? Const Q char. Thank you. So if line at 0 equal to a const q char of hash, then continue. We're not interested in comments. That's the first thing. So let's get that out of the way with. So now we know we've got a line of text. We need to split that down into 2 items. To get our combat component, we also need the UUID. Where's that being held right now? That's being held in the base item object. So let's start this up. Weapon is going to be a combat component. Combat component. Weapon equals a new combat component. Alright, UUID, no viable conversion. Are you little tosspot? Can't do that. Never mind. We should pass the UUID in. I don't want constructors inside of my components, so tough, we're not having it. Combat component. Right, so we've got a combat component. So weapon and that's going to be a UUID. Sorry, UUID. However, we did it within the normal standard way of doing things, I'm hoping. There it is. Right, so we've got the first bit. What do we need next? We need the name. That's your next bit. And that is in our line. So line dot split using space. at 0. Okay, that's our name. Our weapon damage equals a line dot split by space at 1 to int. Did that make sense? Once we have all of that information, we've got a combat component. We can then push that back into an object. We need to create an object. We need to copy that object. And it's in a pointer. Well, that makes it more complicated, doesn't it? Scene. Object. New weapon. Don't call it new weapon. Where we're placing this. We are placing this into something that's referenced, aren't we? Yes. But we are placing this into here. Equals a new. I'm not sure we need this, but we might be able to get rid of it later. We'll see. So we've got this brand new item or object. What's in it? Oh. We need to create a brand new one of these. We already have the information of what the base one has in it. Okay. Okay, so weapon new item. Let's see if we can actually make this object. What have we got? We have a UUID, an entity ID. We've got that. That's going to equal items. Because it's an item entity. I don't really like that either. It's the only one we've got, so we use it. If I could spell it. What else have we got now? Weapon. New item. We had the UUID. Which we can't fill in. Whoops. Let's try down here. This might be a bit better down here. That equals weapon UID. Potential leak of main. Oh, feck. Yeah, there is. You're right. Alright, we'll continue with our leak for a minute. I don't think we should be creating the UUID on the weapon component. Only on the object. Probably. And the last part will be how we're going to word that. Scene? What have you done to me? Component unside. Okay. That one there. It's a void star, okay. Let's see how much of this information we actually need. Comp total won't do. How about combat? Equals weapon. Yeah, I don't like it either. I'm putting you there, we're taking you out. Weapons don't need generic. The object needs a UUID. The weapon component doesn't. Goodbye. You are the weakest link. That's nice to know. Weapon new item. Alright, fair enough. Whatever you say. It's gonna die here, but that's the leak, got you. It's an object. If we place it in here though, does that still exist? Oh, yes, it does. Right, we didn't use base item object. Ah. We don't need to. Because we're creating it all afresh. We don't even need this first part. I'm not even sure that's needed. Right. An interesting idea, though. I get it. Our object isn't complete. Yes, we do need it. That's not correct. For each void star component, in base item object components. That's an int. No. We haven't initialized that. Weapon. That's going to be awkward. It's not going to work. We have to copy it. We can't take the same memory addresses because that's going to be used somewhere else. So we have to take each component and copy it. Well, there's only one component. And that's at default. I don't think it's worth doing. We've got the weapon part done, but we haven't got the base item done. Alright. Is this overcomplicated? Yep. I'm just thinking my way through it all, don't worry. This is just the first pass splatter. I don't like it. We'll look at what's good and bad in a bit. Is there not just a simple way of just copying the whole data? Memcopy. How does Qt deal with memcopy? That's what we're going to do. We're going to memcopy it. Copy it from one memory address to another. Not massive, so it shouldn't be too bad. Got to keep it external. I can't get it on the stack. I've got to keep it away from the stack. Got to keep it away from the CPU. Otherwise it becomes temporary data and we lose it all. Oh, it's got a destination on it. Sorry. What's the int c? I've got a size t and an int c at the end. So the destination is bleh. Whatever it's hiding. Weapon new item. The source will be base item object. Int underscore c and size t n. What the hell are they? No documentation available. I know it needs a count. Or a size. So there is the size thing, isn't it? So that's going to be the size of base item object. I don't know if we can do it by dot size or size. No, we can't. Dereference. What's this int? Oh, wait a minute. No, that's wrong. That's now correct. Do I really need that? It does need the fourth, okay. Int c. Okay, that's my best guess. Is it right? I think we need to look that one up. I have a little bit of uncertainty about it, shall we say. Our memory leaks disappeared. Where's our memory leak disappeared to? Is it because I'm getting the code right now? That's now correct. So weapon items we've taken from the base object, so we don't need to reset that. We do need to give it a new ID, and we do need to add in the new component. The entity ID is given to us, for us. I'm going to put... Is it? Yeah, it's given to us, so... Not really needed. Let's be honest. Alright, this is starting to come together now. New code component. Fill it in. Set up the new item. Add the component and push it back into your weapons. Done. We have been. That's your code. We need to check this. Coffee is required. Let's go start up the coffee. Whilst the kettle is boiling, we shall just take a look at mem copy, shall we? C++. It was mem C copy. Terminating character converted to unsigned char at first. Int C. Mem C copy. Is there not just a mem copy? A straight mem copy without the C. Yeah, there is. Take the C out. That's bothering me. That's not bothering me anymore. And now we've got that memory leak back. Good. That's better. It should be. Why does memc copy get rid of the memory leak? So, that's what people will write. People who are not using Qt Creator won't get this warning. One of the advantages of Qt Creator, I guess. It tells you off. It doesn't say it is a memory leak, it says it's a potential memory leak. And we now know it's to do with this. Alright. Fair enough. There's your code. Finished. That's the first time I've ever seen Poppy angry. At the back door. She's been angry at the back door. Okay. Memory is allocated. Taking true branch. Execution continues on to line 29. Potential leak of memory pointed to. Assuming the condition is true. No, it's not that. I didn't think it was. Is it because it gets deleted at that point? Let's reference this up then. What did I just put there? I put the reference itself. Okay. This is going to be awkward. Okay, what the hell is that? Create. I always get that one wrong. Okay. No matching function. Okay. Why can't I mem copy them? Because they are pointers. Non-const L value reference to type. Standard SharePoint. All right. It's not a leak of memory, but it is a potential leak of memory. You are leaving a hanging or dangling pointer. That's what it's trying to say. I'm going to leave that line in. Oh, it's that bloody continue. That should be the first thing. You can't put the creation before a continue. Thank you. Well done. I knew a cup of coffee would help. Fixed. But you can see how problems can arise. And it was quite right, that is actually a memory leak. Because we had a continuation where it wasn't going to fulfill. It wasn't going to hit that bracket. There was a condition there where it was going to come down after creating something new and jump back up to the top bracket, leaving that something new dangling away, doing nothing. Well done, QT. Good spot. Right, that's our code. Alright, let's test it. Make sure we can build a library. We can. That's good news. Util development. How can we test this? We have an initialize. Let's do it the basic way first. So we will want a Q vector of scene objects. Star. I'm going to take that by reference, aren't I? View weapons. What we're going to do, we're going to return and weapons. I need that to be a const. Don't want it changing. Dereference, please. Thank you. All right. Back to main. We've initialized everything. We've initialized the scene. We've initialized the items. Everything's been done for us. So now we just need a Q vector. Of scene. Sorry. Night. Scene. Objects. Weapon view equals items. Weapons. And of course I've done that wrong. No viable conversion. View list. What's the no viable conversion there? Q list to const Q vector. Oh, the stars are in the wrong place. Alright. Thank you. Right. Now we can debug it, can't we? Yeah, okay. How are we going to debug it? We can use that for loop. Can we use that for loop? Not really. Right, for each night scene. Object. Weapon. In weapon view. What can we get from weapon? We could try and get the component, but I don't really fancy doing that right now. Let's just do the basic information then, and see if it works. That could be interesting. Right, let's do basic information first. Let's do debug. Let's put something together here. So, what's the first thing we've got in weapon? Entity ID. What's the next thing we have in weapon? UUID. Don't know if that'll work. That could be awkward. What else do we know about our weapon? Components. It's got 2 components, that's interesting. It already knows. Component 1, maybe? What will that give us in return? I don't know. We would have to get the component. We can't use it like that, I don't think. And that should be a compile error. Please be a compile error. Yeah. I didn't think you were allowed to do that. But it was a nice thought, wasn't it? UUID. We might get further with that. No. Ooh. Okay, we can't do it this way then. I think we're having problems with our UUID here, so let's just take that out for a second. See what we are allowed to do before we decide on how to do other things. Doesn't like it at all. We might not be getting anything back, I've just realised. Damn it. Where index is less than or equal to weapon view dot size index plus plus it's going to be weapon view. This is where I got it wrong. Oh, I think that's what I did wrong. Bollocks. No, because I put star weapon in here. Control Shift Z. No, I won't do it now. Oh well. There's a size TI going on in that mem copy, I think. Is our mem copy failing? In QString H. Okay, let's find the error. Let's find the error. Error hunting. Okay, we got a sig fault. QString at. I don't understand. Why is that causing an error? Alright, let's find out. So the original code was 0. Line. Okay. Anything? Ah. How do we compare? I can use regular expressions on that. Starts with. Okay. We can use that. What does starts with give us? It'll give us a Latin. Oh, it can give us a QCharC. Ooh. I'm thinking it's still going to be hash though. Does that still give us the error? Yeah, we're not copying this properly. Index out of range. Let's have a look at that. At least we've got some better coding. I said let's have a look at that. Thank you. Index minus 2183. Well, of course it is. That's okay. We haven't gone past that. List output. 4 items. Let's have a look at those 4 items. We have, let's pull this over a bit. We have a hash. This is a comment, which is what we're looking for. We have 1, which is staff 0, 2, which is dagger 1. Okay. Index is now 0. Line is not accessible at this point. Line, hash, this is a comment. In what format? QString. So if the line starts with that, we should just continue back to the top. Okay. Which we do. What's that 4th item? Oh no! That's 4, so it only goes to 3. Which is dagger 1. Oh no, it's -1. Bollocks. Done it. There we go. Weapon entity is 0 and 0 because these are the only entities that we have. The entity number is correct. It's an item. Yay! We have started. That was a bad mistake to make. Maybe we should take off the extra... No. No, I need it in there for something. That's why these aren't working properly. Oh no. It knows not to go there. Right, this is a problem. And it's coming from file read text. And I wanted that in for something else. And it should have worked here and it didn't. So the problem is there. And I knew it wasn't fixed properly, didn't I? The problem's not here. It's there. I remove the... Can we get rid of this rubbish? Thank you. I've removed the end of file character. We should also remove the last return character. Because that's what's creating it. So we'll remove that as well. Right, now it should work. There you go. I think that's better to do it at this level rather than into everything else. That will make my for each loops work now. Good. We've got rid of that. We're doing well. Right, back to main. Right, what else can we do here? Shall we try this unique identity number? Are we just allowed to display it? I still want to try this without putting this back to the for each loop now as well. We'll do that after. Can we just print out a UUID? Are we allowed to do that? We are. They're different. So those are different weapons, and there's only 2 of them. Which is interesting because we only did 2. We did a comment, a staff, and a dagger. So it's worked. We haven't positioned them anywhere. And we haven't given them ownership. That's what we need to think about next. Okay, that's not to be thought about here. But that's your answer. There's your solution. Got it. We have the solution. We can dig more into this. How? There's a good question. I don't think our scene's really going to help us out here, is it? No, we used it for movement, didn't we? So, under systems, movement. Player get position. That's not really much good to us. So, implementation, mobile player. We've got this horrible piece of code, you see, here. Which is fine. Yeah, okay. Let's see if we can duplicate that kind of thing for whatever we've got here. So what we're looking at is a component for combat, was it? Let's have a look. It's got a name and a damage. If we see default and -6, I'll be very disappointed. That's you. And your combat. And what's wrong with component? and combat component. We don't have an ECS system. We do? Yeah. Oh, it's in night. Sorry. My bad. What a fantastic line of text. Right, well that gives us a player position. Well, we'll call it weapon component, combat component. We're looking at weapon items, aren't we? Alright, got weapon component now. Okay, we'll pop it in here. And then we can Q debug it. Weapon component. What do you got? Name? Oh, sugar. 1, 2, 3, 4. Damage. Space. Chunk. Chunk. We'll just put in weapon component. Damage. Do we get anything interesting out of that? Staff damage 0, dagger damage 1. I'm not getting any errors on this lot. That 16 was close though. It works. Instant. This is a precursor condition. This is an initialization. This can be done anywhere. In any system. So what we have here is actually the setup. Here we have the system requirements. And here we have an example on data access. Doesn't really get much better than that, does it? Full system, done. Is it gold? Is it hell? I'm okay with the result though. UUIDs, we haven't been able to assign them yet. I'm a bit worried when we do come to that. ECS is working, obviously. Why is that out of line? Oh, because I didn't use tabs. Who cares? Alright. There is your item system. 3 hours complete item system from start to scratch, and all you have to do then is add your own categories and your own components. Not hard. Alright, just make sure we get a rebuild on you. Okay, we're on 4 seconds now for our... Can I have a rebuild on you? Are we okay with that? Two seconds, yeah. Okay, I can't stay on main for this any longer. Because this, I can't put this up. I'm sorry, but I'm not putting that code up. Not for usage. This part's okay, because it's obvious what you do next. If you want to do armor, you put a Q vector, scene object, m_armor. If you want to do cups, and plates, or dishes, I don't know, food, yeah, you got the idea. Just make a big list of these things. If you got any more sense than that, you probably mapped them at that point. Yeah, we've got enough to work with. How can we store this heap of garbage that I've written? Well. Does this give me any help? What should we call this then? I just call it development. Dev. Okay, we're on dev now. Pull. We'll submit that. Right, local dev now exists. Okay, development branch change to midnight. Close project, we're not dealing with you. We'll come back to that. Oh no, midnight's going to go in anyway. Oh, that's fine. So that's the first pass. for the item warehouse. Tested. Tested gives correct readout. Okay, commit. Push to and pull from, submit. Okay, we're done. Okay. Make sure the dev is now showing the correct information. It is. All errors have been removed. Very simplistic, very easy piece of development. Okay, we've got dice rolling. We've now got the QD bugs in now for data access. I'm happy with that. Well done, get cracking. You didn't fail me this time. Let's get rid of some of these, because these are all past experimentals. Get cracking, you can go back. It's okay, boy. Sit. Is this any good? Is it what you expected? Is it more complicated than you expected? Obviously, you add more stats. I mean, it doesn't take a brainy person to work that one out. But at the moment, on the file that we're using, we only have name and damage. We haven't even created a text file for this at this point. And of course, you just assign them. This is not a great piece of work. What may shock you is the entity ID stays the same. Remember, I said we're going to have absolutely bajillions of entities. Well, we do. I didn't say they're all going to be in the registry. The registry handles the categories more than anything else, and the base item objects, which you copy from. So your ECS system and your scene holds all of your base objects. It's these wonderful little things that we are going to develop on the side that will extend the ECS into something magical. That's the objective of this part anyway, but I just wanted to show you how you could do it using items as an example. So it's not very hard to create items. We can now create items by doing a little bit of code here and an update to a text file, which is independent from the code. That can be done externally. And it's irrelevant if the code's compiled or not to that stage, because that text file is read in at this point here. So file read text comes in here. So that text file can be changed at any point up until you load that in at runtime. And if your text file changes, you can ask people to download it and use the new text file instead of downloading the whole goddamn program. But there is that problem that it is now connected to these lines here, so you would still have to change the program. Oh dear. Now you see the problem. It's no longer independent. We've linked it in. So what's it missing? Our text file. Can you see the problem? You have to unlink. Or generate a system that isn't going to be changed. I prefer the second one. Remember, we're making a self-balancing system, so let's make a system that doesn't have to be changed. Voila! Problem solved. There's your code. Just complete your system properly. And don't publish it with half a system. Looking at you, AAA games. Looking at you. So, our unique identifications are working. Magic. That means we can now assign objects to owners. Or we can now develop ownership. I think it's pretty obvious how that's done. What you don't do is memcopy these items that you create. There's only one of each, but you can have multiple of the same item. Oh. So how many of these do we need? Bajillions. Enough for everybody! Can you see your next problem? Oh, I'm saying, can you see problems? No, there aren't any problems, there's just solutions. The obvious solution is you don't do this. This is example code. You don't want to be generating items on initialization. You want to generate items on the fly. Otherwise, you can have more items than are needed. That's a bit wasteful. All right, we okay with that? Are we okay that this is only example code? Because there's no way I'm gold coding this. There's no way I'm putting this out. I'll leave it in the development system. Yeah, I'm happy to do that. But there's no way I'm putting that bunch of rubbish into into the midnight code, the engine code. So if you are going to generate items on the fly, we need to look at this in a slightly different way. We've got a full item system now, which is capable of generating items as objects that are unique. We've seen how to add a combat component. That was difficult, wasn't it? The only thing that I didn't like was that mem copy. Not really that bothered about it. I prefer it done that way than any other way. I am a C programmer more than I am C++. The thing about this piece of code is these brackets are killing off things. That gets killed. That gets killed. These don't last. The only thing that lasts out of the whole thing is that line there. So that's the only line that is effective. Effectively does anything. The rest is garbage. There must be a better way of doing it than that. This is actually a very simple parser, I've just realised. Using the ECS item as a template. I didn't check on its position, did I? And create the new component to be added to our item. Alright, we'll take that out. Does it run properly? Should give the same results. Yes, it does. Good. add data to the new object. What we called it. To the new object, yeah. And we can just store the object. Store the object for reference. Later use. That's basically all we're doing. I think that's fair enough. That's a read file. There we go. Anybody who has any problems with that code, let me know. That's all part of the same system. This is create a base item entity within the ECS. Within the ECS, full stop. Okay. I think we're done on that piece of horrible code. But that's what a 13-year-old kid would have said to that big mess we made of ideas. And it's pretty simplistic, don't you think, compared to the ideas that were created. But all of those ideas that were on that board are actually in here. There, let's have a look at that board again. Let's see if I can explain it properly. So we had table, model, categories. Can't use that one, use that one. Carry on doing this Q vector scene object and weapons for categories. You're going to create a table of categories. Tree model containing items. Oops, not that one. There it is. It's a Q vector. There's our tree model. We've just done it in one line. There's our tree model. It's a linear tree. It's held in a vector, one after another. It's not very tree-like, let's put it that way. It can be changed, of course. It's more like a stick than a tree. But it's there. we have completed all of that with tokenization and UUID in a very simplified fashion. All of these ideas up here. Insta-retrieve. Well, we've shown we've got that. We were able to just dump it all out onto the screen quite happily. If you've got a million of them, the screen might get a bit full. Interface? We haven't written one. We've written an example, but we haven't written an interface. And we have no systems to use this piece of code. But it's there. I suppose we should write an interface for it, but let's not. Not yet. Right, so that's where we're up to. So we have a first pass with no interface or systems. Fine, that'll do. You're probably thinking that's a good piece of code. Yeah, right. So we have now completed pass 1. Tested. We are generating individual items without a problem. No interface. No interface. And no systems. Give you a tick. I think that's it. We're done. What are we doing next? I was looking at AI. Interestingly. At least our research board's got stuff on it now. That shouldn't really be the research board, should it? I just realised. Okay, we've done random. That's where my coffee went to. God damn you. Just pop down here a minute. Okay. That's okay. So, model warehouse. No, it's not. That comes later. Item warehouse. We have interfaces. We want an interface. Implementation. And systems. So we can put it here. Pass 1 complete. We use a 3 pass. Completed. And tested. Oh, that didn't work. So, what do you want to do next? That's what we completed today. That's my goal, is to complete something. I am not doing pass 2 on this because of the reasons I have just stated, that is not the way we want the system to work. I just wanted to put together something to prove that the system works in a lot more simple fashion than people believe it to work. Call it a proof of concept. Pass 1 completed. Proof of concept. Done. Good. So it's no longer a theory, it's an actual thing. We do have a thing. We can't develop it yet properly without developing the player. Maybe developing the world a bit. I don't know. You probably can develop it without doing all of that. I'm going to put the kettle on, I don't care. You lot think what you want next. What do you want? And it doesn't have to be based on the current project, by the way. It can be based on anything. You can ask for anything you wish. Your choice, peeps. Be right back. I'm hoping that from that proof of concept that you've now realised that there's a lot more to writing an items system than just some kind of concept. Better put that up all and get cracking. Alright, let's get that all sorted out then. Use a different mouse even. What we were doing, item warehouse. There we go. Done, done, done. Can you get out of my way, please? Thank you. You're done. Okay, you're done. Check. Okay, everything's up. You're done. I'll leave that running. That machine can stay running. What are we on now? We are going back to research. So there's quite a lot more, probably, to this. Could do with cleaning this board, couldn't I? All interesting stuff, I'm sure. I'm going to start this board again anyway. Because I was using it for this advert, wasn't I? This trailer, that port. So let's clean off our research board and start on something interesting. Something that we might not be able to program. Because nobody's ever programmed it. And there's a reason why nobody's ever programmed it, and I'm going to give you the reason. It's a simple one. Computers were designed wrong. Put that back onto brush. Reset view origin. Okay, zoom 2 points. Yep, that's lovely. Right. Oh dear. That happened again, didn't it? Still haven't got used to this system. We had it resized to a silly thing, didn't we? Oh yeah. What do you know about AI? Let's mess around a bit with our thoughts. So AI. Not what you think it is. I'm just hoping that OBS records this, because if it doesn't, I'm not doing it again. So anybody who doesn't hear this might just miss out on something that's exceptional. Tough. Artificial intelligence. What is it? It is an artificial way of representing the human intelligence. So the real question when you come to program this is, what is human intelligence? And don't say the average intelligence of a human being is that of a gnat. I already know that. I don't like human beings. They destroy the world. So, artificial intelligence. Is a computer representation or an artificial representation, possibly computerized, of the human brain, because that's what we call intelligence. It's a very, very misused word, intelligence, I believe, on this planet. Ask any dolphin. Where would you start? Well, you'd start in the wrong place, is the answer. Because you'd start with the wrong question. Oh, deep learning. Oh, that exists. That's a fecking joke. You tried it. 10 days to get it to learn anything. It can't speak, it can't see properly. It's not AI. Deep learning is an algorithm on data sets which predicts an outcome, and they call it AI. I can predict an outcome. I can predict that the world will end tomorrow. It won't, but I can predict it. That's not intelligence. That's prediction. And prediction you cannot do. The human cannot predict, therefore it is impossible to program. You cannot do artificial prediction. They're trying. Bless them. Otherwise we'd all be rich on the stock market now, wouldn't we? So no, you can't do it. You can't predict what's the Wimbledon final result's going to be this year at tennis. No. You don't have a hope in hell. You could look at all the parameters and make a guess. So you can program guessing. Well, I could do that with one single if statement. Why do they need a bloody machine to learn it? Idiots. Sorry. Pet hate. Misappropriation of a title. If you look up artificial intelligence on Google today, you will come up with page after page after page of deep learning guessing They've somehow convinced themselves by using strange language and inventing new words half the time that they are on the right track for artificial intelligence. Well, I'm about to blow that out of the water in about 5 minutes. What can a computer do? What can intelligence do? This is a subject that is very, very, very close to my heart. You can argue with me all you want in the comments. It's quite fine. Everything I am about to say is completely wrong in the face of the establishment today. It is my opinion. It is not fact. But what I'm going to write on this board are facts. What can a computer do? It can hold a value of 1 or 0. What can intelligence do? This is funny. Hold a value of 1 to 0. And that's why they can't program it. Because they haven't designed the computer to do so. You see, when it comes down to AI, it revolves around the rule of 3. So AI is the rule of 3. Now, if you don't know what the rule of 3 is, it's quite simple. There are 2 options. There is 1 degree to the left, to maximum left. There is 1 degree to the maximum right, and of course there is 1 degree in the center. There are 3 possibilities to any one state. But the rule of 3 has a caveat. Like computers, it counts from 0. So there is a hidden 4th state. 0 state, we'll call it. In other words, you ask somebody a question and they go, I don't know. That's 0 state. If you ask the question, what's 2 plus 2? Some people will say 4. Some people will say 100. They are both right. But a computer can't do that. Some people would say A. I would say A. No, I wouldn't. No, that's not a good one. That's 5 plus 5, isn't it? 5 plus 5 equals A. People might know what I'm talking about. Really good at writing in paint, that's good. 2 plus 2 equals 22. There we go, Nano, well done. 2 plus 2 equals 22. That's what a computer can't do in its current state and mechanics. It can't do what you've just done. And that's the whole point. That's the answer a computer should come up with. But it doesn't. It should come up with 22. It could be 4. It could be 100 if you're thinking in binary. But you get the point. For the simplest of questions, you cannot resolve every existing answer because there are an infinite possibilities of answers between 1 and 0, where 0 is wrong and 1 is correct. There are many shades of grey in between. A computer is black or white. And this is where we come to the rule of 3. This is what I've worked on all of my life. How I can apply the rule of 3 to computers, and how I can apply the rule of 3 to this 1 or 0, and how it translates into what we call human intelligence. There's no wrong answer in human intelligence. So the 0 disappears. We'll leave it in for now. I won't go into that. That might get a bit too deep. So, the rule of 3 means you have 1, 2, 3 avenues of progression. And I said, computers, remember, the human brain is electronic. It's a computer. It's a biological computer that uses electricity on and off, 1 or 0. So how does the human brain convert the 1 or 0 into a 1 to 0? It has a 0. A donut! Well, hey, I've just drawn a donut. We'll put a line through it to make sure it looks like a 0. The node itself. What do they call it in biology? A brain cell? A node? And they fire off down pathways which grow. Oh, I've just drawn it. Oh dear. I've just drawn the human brain. What do they call it? A donut. The donut rule. Yeah. We'll call it the donut rule. Yeah. It's the donut that does it. The donut matters more than the 1, 2 and 3 because the donut actually stores the data. The donut is the data, the 1 or the 0. The 1, 2 and 3 adjust that data. Logic. A computer is made up of logic, and logic is and, NAND, or gates, NOR gates, and, NAND, or NOR gates. You can represent all logic within of those Boolean algebraic formats. So what a computer can do. Boolean. And it was designed to do Boolean algebra, to solve to create solutions. And that's how languages were born that we now use as programming languages. What can intelligence do? Well, it's not Boolean, is it? I'm going to call it trilinear. Which means you can go down the yes path, the no path, and hop over to other paths. Other, you know, be creative. People who aren't creative have their other path blocked. Let's put it that way. They use trilinear reasoning, which means no matter what the question you ask, the answer you get may have no relevance to the question. One of the answers I give to trolls on the stream is, what's that to do with the price of fish? And if they take that as an offence, then that's not my problem. If they then come back and tell me what the price of fish is, then I'm listening. Because I want to know how they came to that thought, why they didn't react badly. And I do it to people. And I am horrible, and I am nasty. Because I don't like people. I like this kind of concept. Can you program the rule of 3 on a computer? Well, no, because you would need an extra value, wouldn't you? You'd need an extra 2 values, in fact. How does the human brain do that? Well, it's simple. It joins those nodes together. Not in any Boolean way, but in a trilinear reasoning way. When you see something and you learn something, your brain changes. The pathways in your brain actually grow and die. It changes. The state of your mind is in flux at all times. That's why we need sleep. Sleep is a mechanism where the brain is given time to acclimatise itself to its new state and to re-go over the experiences of the awake time. That's why humans and that's why animals, anything with a brain, sleeps. You don't need sleep. That is a biological fact. But without sleep, your thoughts go into this foggy bank and things become difficult to work with. Your dexterity decreases, your ability to move decreases, your ability to do simple tasks decreases, because your brain can't cope with its flux, its change of state. It can't get the right pathways. And that's why we have a conscious and a subconscious. Our conscious self is our immediate solution self. Our subconscious self is the governing underlying operating system that controls the redirections, the flux, how things are generating and how things are dying, how you forget things. We call it memory. There's no such thing. You can have a buried memory that can come out 40 years later from a smell, from a touch, from the wind breezing your ear. That can spark a memory. Your brain is miswired at all times. Creative people use that and call it inspiration. Non-creative people go, oh, that's a bloody nuisance. I know, because I have no immediate memory. I have a lot of problems, as you know, with remembering things, and I have to look a lot of things up. I know how to do them. I know what I'm supposed to do, but I can't do it. Because my immediate memory and my consciousness is a black box. It's empty. And it is now permanently empty. My brain is miswired. It's miswired so badly that it no longer has a conscious state. How do I operate on a day-to-day basis? How do I make a cup of coffee? I just try and make a cup of coffee and hope it works. And I do fail. Yes, I can fail to make a cup of coffee. This all becomes interesting. To me especially. Because it means that I can encapsulate within my consciousness the rule of three and see it for what it actually is. Very, very few people can do that. I think a few painters could, people like Dali. It's a very special ability. You lose a lot for it. You lose your ability to do a lot. But the ability to look at something and say, oh, I know that's wrong, in a black and white way, just like a computer can, I can do that. I can look at a tree and say, ah, that's wrong. There's something wrong with that tree. Impressionists can do it. I would say that the closest you can get to computer programming is painting. Painting on a canvas. Probably using oils, not watercolour. It's very, very similar. Because what you're doing is you are composing something that will be set in stone. You are creating a program which a person can look at, absorb, and that will take that picture into their subconscious, and that will be rewired into their brain as a program, which they can then recall. And they will recall that picture. And that's how your brain works. I know this because I had to study my brain to get it to bloody well work. So, we've got this problem now that computers have been built wrong. A computer is built with two inputs and one output, an AND or gate, which you can then NAND or NOR, not them. And that's how you get Boolean algebra. Each one has, oh, there's an inverter as well, but that's used for the knotting. The inverter we can scrap. The inverter's not necessary. The whole point to this is the logic gate itself is 2 inputs. How many inputs are there here? There's 4. How many outputs are there? 3. We built computers wrong, didn't we? Now you're going to make coffee, Nano. What would happen if you programmed a new logic gate? And that was what I thought. Don't program artificial intelligence. Let's program a new logic gate. Because that's what this is. It doesn't exist yet. It doesn't have a name. Neuron. Found it. Sorry, it takes me a while. Use the right keyboard, I know. There we go. There is a picture of a neuron. Can you see what I see? Can you see something? They have dendrites, an axon terminal, a soma, which is a fluid for conductivity, a nucleus, which can have a positive or a negative charge, depending on the state of the fluid. And it can reach out. But look at these, this is how they depict it. This is depicted on purpose because these pathways can split. What's this for? That's a connection interface. To what? Incoming, maybe? It's in a similar fashion to these. Maybe these grow into and touch and fix onto these. Because these fixing onto these might be bad. Because anything coming in has to be regulated. I think that was a very simplistic way of putting it. But look at the pictures. That's the schematic I put for kids. All right. Yeah, and that's what it looks on the outside. That's an actual brain cell. But you can see how our brains wire up, and these wires break and will grow and will try and join other places. Or they connect via other nodes. The nodes. All they are is a node with pathways. Well, I think I've just drawn that, so. A node with pathways. So one of these is a main input. Interesting. So instead of having 2 inputs and 1 output, this has 1 input and 2 outputs. That's impossible, according to Boolean algebra. So we'd have to redefine this node, this thing. We'd have to make a computer definition of a brain cell to be able to do AI. Has anybody done that? I'm going to get rid of this keyboard, it's annoying me now. Okay. There you go. That's what they came up with in programming. Can you see the problem? And it's why they can't do it. Where's the other line? There's a line missing, for starters. This is wrong. I can look at it and state that it is wrong. Here we go. Neuron programming. Conventions used in a document. Oh, some music just started. Okay. Giving it properties. Then membrane properties. Point process. Running a simulation. And oh, it will do something stupid. But it won't be a neuron. Because it's missing a link. They got it wrong. Try it out. Try it out. There is a missing link. Their system doesn't follow the rule of 3. It follows Boolean. You first have to define a new system. So, if anybody wants to continue the AI research, of which I've done a bit, I'm not going to tell you how much, probably too much. And I haven't come across one person who has done it right. I even went through all of the Southampton University in the UK's artificial intelligence papers to find how far along they've got. They've got to the stage where they can control a robot and do visual recognition. That's it. I'd give them a round of applause, but I was looking at that in the 80s and 90s. And it's still the same today. Except now they've gone on this stupidity of artificial intelligence, deep learning, guessing games thing. Very disappointing. Very disappointing indeed. But hey ho. There we go. I thought I'd do that for my little lecture-y bit today, as we have been so successful with the programming. What should we do next? I am not going to write this. I am not going to show you how to write this. If somebody can't work it out for after what I've said, God help humanity. Right, that's AI. I'm not doing any more on that today. So what are we on next? We are on... I think we might be able to progress now into different areas. Does anybody want anything doing themselves, for themselves, or want me to look at things for them? We have our Rana project now with utility development, as far as I'm concerned, complete. Although it's still got a development status on it, which it should have. We've got now our gold code, our source. We can transfer over the utilities, can't we? The utilities are gold. They passed 1, 2 and 3. They've been through all 3 passes. And the code is good. Nucleus is a donut and the dendrils are the 1, 2, 3. Yes, you're quite right there, Nano. You spotted it. And you're probably not a geneticist. Because that's where I had to learn it from. I didn't look it up under brain science, put it that way, or under neurology. Neurology is even worse than computer science. Oh, by the way, if you ever want to know what a science is a fictional realm in which nothing can be proven. That is the definition of a science. I love physics. God, I love physics. I also like taking the piss out of them. Alright, we can have some utilities. Where should we put them? We can put them in here, can't we? Alright, let's do that then. What we got? Utility development. We decided that we didn't want to complete on the warehouse because of the systems that are required to satisfy gold code are impossible to do straight away. We can do a concept, a proof of concept, which we've done. That's been programmed now. But these utilities don't need to be here anymore. So they can go in here. I think that's the best way of doing it. Just get rid of that other mouse, it's interfering. I know, I have a very, very strange outlook on life. Okay, so under what we got here? Utility development. Okay, our core has gone down. Pro. Still got utilities here. So we'll have to take those out. We can't keep the utilities in this file. This is how I do things. I don't do it probably the proper way, but I don't care that much usually. Okay, that's alright. So we can save that. That code's complete. We go to main. All we do is we change that over to that. It's been moved to recognize that. Okay, that's fine. Just load up midnight. if we go through to core, we can add an existing directory, and we'll take utils. Yeah, whatever, don't care. Yeah, don't care. Make sure that that will work. Half of this stuff isn't needed. But I'm happy. It doesn't matter whether it's needed or not. Not with header files anyway. Okay, that works. And our test. Staff, damage 0, dagger, damage 1. Yeah, press return. UIDs are working. No problems with that. It's updated. Amazing, isn't it? How simple it is to do things. Okay. Complete. Utils. Now in midnight. What do you call it? Midnight library. Static. There we go. That's your commit. So the only thing we're left with under development is the item warehouse, which is correct. I'll make it look easy, I know. My lectures are the best, thank you. I want to try and give ideas out as much as possible, because that's what the state of today's programming is missing, unfortunately. We're not pushing to development, are we? Yes, we are. Ooh, sugar. Alright, we'll push to development. We're still in development. I am going to have to finish the items warehouse then. Otherwise we can't come out of development and join those two up. Damn. Right, that's all up on GitHub for you. It's on the development branch though, please note. It's here in development. You won't find it on the main at this point in time. So it's in core, utilities. These now are finalized. These utilities will be used. They're very good actually. They are better than I usually would put up on the internet, put it that way. Be honest about that. I would normally only push gold code to my employer. As I no longer have an employer, and I am retired, I'm going to give it to you lot for free. Remember, the code that I am giving you is to be developed yourself. Further, it is not pre-developed. What you are being given is a foundation of code to build your own systems on. And they've all been tested and they all work. We just need to get this item warehouse to work. Right, back to the drawing board, I'm sorry. We have all this initialize garbage. That's going to have to go. That's correct, that's correct. The only thing I disagree with is mworld is instantiated before mweapons. Is that correct? Yeah, that's fine then. Order matters. This is being passed in as a shared unique reference pointer and will kill itself when everybody forgets about it. So we don't need to delete it. Good. Yeah, I'm happy with that. I'm just not... it's this. Please note you want to generate items on the fly. Generating items on the fly. This is good. Yeah, I love doing this kind of stuff. How are we going to do it? Well... What day are we on? We're on a Friday. Well, we could have finished it. No, we can't finish it today. We're at 25 past. I'm not supposed to be doing any programming now. We've done all the programming. It's here. So past 2, turning this into what I would call gold code. Let's open it up. So I've got pass 1 complete. Let's start looking at pass 2, shall we? Get ourselves ready for the next stage. Okay. Pass 2. We'll need a hash define here. Items to be created on the fly. So pass 2 will start off with a revisit pass 1. To implement item creation. How's this going to look? We are going to have what inputs have we got? Let's have a look at, because we've already created this, we know what's in this code. This pass 1. So we're already good up to that point. Let's have a look at current inputs. We have a text file, a button which stops it from drawing when I click it by accident, a text file. We have an ECS system. What else have we got there as an input? Nothing really. That's all we've got. Let's check back. Let's not be stupid. Let's check back. The scene. The world. Scene. Yeah, scene. Okay. I've forgotten that. ECS. We'll call it scene. That's an input, not an output. We're not outputting anything back to the scene. And we're not outputting anything back to a text file. These are both inputs. Strange, but true. Anything else I have forgotten here? You can usually tell by the header file. Yeah, world. Our outputs is a vector of weapons, currently. We can expand upon that if we want to. Current output. So this is actually very, very simple then, isn't it? Didn't do that right. I felt my hand go. A vector of weapons is the only output we have currently. And we need to implement some kind of interface now. We need an interface to request create item. Category. And type. Now, category and type sounds like the same bloody thing, doesn't it? So it's category and name. There's the biggie. This is awkward. There's your problem. This is where we need the solution. You can see I wrote it wrong straight away. That means we need a solution. Little question mark on that. Make that into a better bracket. Category and name. Well, categories are easy, aren't they, really? We could change that into a text file name. But how do we know what's in the text file to create? Chicken or egg? Chicken or egg? Which one came first? The text file with the name in it, or the name that we look up in the text file? Which comes first? Well, I've already told you the answers to this, so this is an easy answer. It's the text file comes first. So how the hell can we ask for a name? We can't. We can ask it to create a weapon. But we need some way to identify and choose. There we go. It's coming together now. We need some way to identify and choose which item to create. We open a treasure chest. It's full of items. We look through the items. We'd see something that's shiny and glints. We pick it up. What the hell is it? Dunno. Doesn't make for a good RPG, does it? Okay, we have narrowed the whole of the system that we require down to one thing. And that's this. There's your system. Input, output, can't change that. Interface, don't want to change that. It's that. We've got the code. But what we don't have is the system to create the interface. So somehow, we need to have a system in place which has already identified all of the items or possible outcomes that there can be. A category is easy. It's a text file name. We can use that path as an input from a text file. We can search through that text file for the line that starts with the name. So that's a Q string. That's easy. But what name can we ask for? Anybody got any solutions? We've got a warehouse full of empty shelves. Well, actually, we haven't. We've got a warehouse full of empty shelves, except one of them shelves has 2 items now placed on it, a staff and a dagger. Nobody owns them. They're just lying there on the shelf. Meow. I know, it's that time of day. Thank you, Poppy. Can we only identify those things which we have created? I've already said no, that's not the right way to go, because then you're just wasting time on items that might never get used. Those will get destroyed. Well, the answer's in the text file. We know that. And we know what text files we've got, but if we add a new text file, how does the system know? Okay, we can solve that straight away with a file handling. it reads the directory, and notes any file ending in .item, for instance. So we can use the .item system in directories to create a list of item files. So that could be useful. It's an idea. Create a list of .item files. There's that idea. Anything else? Any other ideas? That's okay as an idea. Bit inefficient, don't you think? Having to read somebody's, well, they're not hard drives anymore, SSDs. That's not so inefficient when you think about it, because SSDs are solid state memory. So it's pretty fast. But it's not the fastest. Because, again, they've designed them wrong. They've put solid state memory into a device which they then have a front end of a hard drive on. So it actually accesses your solid state memory as if it is a hard drive. What idiots. Why don't they just put solid state memory in there and just say, hey, freely access it through a bus? Would have been a damn sight faster. But they're idiots. They just like to complicate things, so they can try and sell these things and make money out of it and make them faster later. And basically undervalue the idea of something called progress. But then again, I'm not in the industry anymore and I don't care. Well. So we could do that. It's inefficient because of the way that manufacturers have made their SSDs. So I'm going to hesitate on that. What else could we do? We could have a fixed file set, which we load up, and that's everything. Limitations on size. Also, files can get very, very long. So I would supplement this with includes. And this is why C++ has include files. If you've ever wondered why. So you could have one file that is called items, or items.item, or items.text. Doesn't matter what it's called. And in that file, it just includes all of the other files. So you read that one file, and you load up all the other files that are included from that one file. And that's why hash include is used in C++. because having a fixed file set limits you badly. So we've got the solution for that. We're taking it straight from the C++ language. Wait, you can do that? Access an SSD through a RAM bus instead? That would be awesome. Well, of course you bloody well can. It's RAM. What do you think's inside that little black box? Oh, God. They really sold this one to people well, didn't they? Eh? Oh, this little black box is 1,000 times faster than a hard drive. But it's damn 1,000 times slower than your main memory. Why? It is main memory. It's just in a little black box. You bloody idiots. It's the same with pen drives, by the way. You know, those little pen drives that you stick in the side of your machine and you can store things on them. It's just a little black box with memory chips on. Why is it so slow? Because they decided to access it through a USB instead of a memory bus. And then sell it to people and tell them it was the best thing since sliced bread. And got away with it. I'm not into consumerism. I just like to laugh at the things that people do. Especially in the computer world. I think it's amazing. I think it's amazing what they've got away with. I mean, Windows is the biggest con trick in the lifetime of humanity. They have sold it to you how many times? Bloody hell. It must be the most sold and resold piece of software in the history of computers. I think it might even top the sales of the Bible. My God. That's saying something. I can't put fact to that, but I wish I could. I'm not going to research it and I don't care. But somebody saw us coming, didn't they? Eh, Mr. Gates? You saw a flock of seagulls wallowing down the road like sheep. Jesus. And here I am using it. Oh dear. Right, so we've got this file business sorted out. We can use a fixed file set. Actually, we can use a single fixed file and include from that file all the other files that we need. So instead of a fixed file set, we can just scrap that idea. Don't need you. We don't need a set of files. We just need a fixed file with includes in it. We could call it main. No, don't go there. Alright. So we've solved the top one. How do we choose this item? How can we choose an item that exists? You can't, is the answer. And I've already said it, you can't. So don't. And there's your solution. This can not be done. So, don't do it. There's your answer. Right, the system's complete then. You're thinking, but you haven't got a solution. Yes, that is the solution. We need some way to identify and choose which item to create. This cannot be done, so don't do it. We have a name. What this means is that when we ask our program to create an item, it can fail. The item may not belong in the universe. If it fails, what do we do? Don't do what you can't do. Do what you can do. You thought it was magic inside. It's a little black box of magic jiggly things. It is if I ever get hold of them. I stick matrices inside them. They're little black boxes of jiggly numbers that nobody understands except me. Oh well. We can request an item. If it fails because that item doesn't exist within our system, what do we do? You're going to see a beautiful system suddenly appear. Invent a new item and add it to an item file. We have a staff and a dagger. What happens if I want a sword? I request it to make me a sword. The system then has to invent a new item called a sword and add it to an item file for future reference, because I may request another sword later on. That's the answer. Have you noticed I haven't been adding to that item file any more items? Do you now know why? Is that how you spell invent? Doesn't look right to me. It is. Oh, what a horrible word. Looks horrible in type. Yeah, it's 15 degrees C here. It's getting hot. Now you're going to say, oh, hold on a minute, you're going to invent a new item? Yeah. How hard's that? We have an ECS system. We can easily work out categories. Let's just, for simplistic sake, say that the system itself has its own set of item files, which it creates itself and updates itself as more knowledge is gained about that item. A self-updating system with its own private files, not the user files over here. These are the user's files, its own files. Which you can specify as categories, like weapon, a weapons file. It could load up everything from the user files and then splatter them into its own files if it wants to. But there's no real point in doing that. The user might want to change them. So we have come up with a parallel system. So we have two. Why didn't that work? Because I was holding it wrong. Oh, now I'm stuck. I don't know if that's right. And I think that says it all. I think that's what we're going to do. But you can see why I didn't start with this. You can see now why I started with a proof of concept. To do this from the beginning, we wouldn't have known the problems and we wouldn't have known how to come about the solutions to get to this. There would be no way you could do this from scratch, from blank. You need your proof of concept to realise that you have your inputs and your outputs, and all you need is your create item. Our proof of concept just initializes the items that we have or we already know about. From the proof of concept, we can now create on the fly any item you can think of if we implement this system. And the Midnight Engine doesn't even have to know that the item exists. And on that note, I should say on that bombshell, I'm going to love you and leave you. I want food. The cat wants food. Okay, did we do good? So this is Pass 2. Pass 2 is a redevelopment of Pass 1. We are then going to have to do Pass 2 again, because this is cyclic. Pass 2 is handing back to Pass 1, because we only did a proof of concept. So that's the whole item warehouse on the screen there. So that's the whole code in English thoughts. But you can now see how artificial intelligence, that little lecture that I gave about artificial intelligence and the way that a computer would come to this, If a computer tried to generate this code, it would not have the ability to circle that and say, this cannot be done, don't do it. It would return error. You couldn't get a computer to program this. And that's why I'm interested in AI. Because I think AI could program this better than we could as humans. Right, we have now kept to the big underlining, items to be created on the fly. We now have a system with two parallel file systems, which means we can use the same functions on both because they are parallel. We only need one set of functions, but two systems. We have a theoretical idea of being able to invent a new item and add it to our item file for future reference. We have everything we need for items, just within this simplistic idea. I wonder how many of those role-playing games out there use this. None? You're going to find out why they don't use this. Because you're going to give the power to the player. Because if we are going to invent a new item, the item data set has to be defined somehow. You can define that from specifics, the weight of the item, the type of the item, the tech level of the item, the technology level of the item. There are some specifics which we can derive data from. We don't need to invent. But there's going to be little bits of data in there, I have a feeling, that will require some input from an external source like a human being. And at that point, your game has to be self-balancing. Because no matter what that human being types in, the resulting item must be balanced within your game. And I'm going to show you how to do that. I haven't talked about the game system too much or about the self-balancing techniques that we're going to use, but they are going to be there. We are now going to have to define an item at long last. What is an item? What can an item have? That kind of thing. We're not going to do it all at once. We're going to do it bit by bit, I think. We're going to start off with what we've got. We'll get that working first. Then we will do more with it, I think. I think it's up to the person who uses the system to, to develop their own game with, to do more with it. But I don't know, I might do more with it myself. But I don't want to restrict the creativity of game makers. I want to give them the base code, the foundation code. So that's what we're going to do. We're going to do a set of foundation code for this with the data that we have. And it's going to be interesting. That's where we're up to. I hope this doesn't cancel all the sound on my video again. We'll see. Are we okay in here? We're up to date, aren't we? Git cracking. Yeah, we've done git cracking. Alrighty. I want to thank you all. I want to thank everybody that's passed by today. And I want to remind you all that I'm not doing this for me. This is a games club. If you come to me with some code or an idea for something and you want... I can only give advice. I can't Yeah, I think that's the best way of putting it. If you want advice on how to go about it, then I'm all ears. All ears. People will have what they might consider stupid questions. I don't consider any of them stupid because I've possibly never thought about them before. Bear that in mind. And I wouldn't mind if somebody comes up with things that I've never thought about. How do we get out of this damn thing? There we go. In the meantime, it's tea time. Go get yourselves fed. Cheers, Nano. Thanks for the input. Really helpful, actually. I'm going to go and have a look at this video and over my tea find out whether it's recorded properly or not and whether we're going to be using OBS tomorrow. I will be back tomorrow and yeah, I think we should have some fun with it.